everyone, this is Dr. Esperanza at welcome sa aking YouTube channel. At kung nagsastruggle kayo sa pagkuha nyo ng klase nyo sa algebra or even sa calculus, marahil yung inyong fundamentals sa fraction is a little bit shaky. And for today, magsisit-in kayo sa klase ko para maintindihan nyo kung bakit mahalaga na marunong kayong mag-add, subtract, multiply, divide, at mag-simplify ng fraction using the factoring technique and connection to algebra and calculus. I'm glad that you're here because it's all about math fundamentals. Now, fractions, this is going to help you understand numbers better, and it will also help build your confidence better because a lot of students hate fractions, and once you conquer that fear of dealing with fractions, you'll be able to have that confidence to be in a math class and understand a math problem better because really fundamental is everything in math. Just like what I mentioned a while ago, the multiplication table is key in understanding fraction. Because it breaks down your numbers. And also in mathematics, just like in any complex profession, people or doctors, engineers, medical professionals, nurses, scientists, architects, they are paid really, really well because they know how to do things and they're equally good in undoing things. And that is basically what the concept of fractions. You need to learn how to undo those numbers and see those numbers as factors of a certain numbers or how you will modify numbers. So prime numbers. Do you still remember your prime numbers? Do you know what prime numbers are? Do you have an idea what prime numbers are?
Any number divisible by itself.
So give me an example of a prime number. 11 is a prime number. 3 is a prime number. 7 is a prime number. So we're starting it off with a good definition of prime number. Now, what is the smallest prime number?
1. No, 0.
0?
It's 2.
2?
2 is the smallest prime number, not 0, not 1. Because 1 is a little bit special because 1, it is divisible by itself, true? But the formal definition of a prime number is that it needs to be a factor or divisible by the number itself and 1.
So you need at least 2 parts.
2 parts. And 1 has 1, 1, 1, 1, 1, 1, 1, and it's still 1, right? So 2 is your smallest prime number. So, between 0 and 12, can you please list down the prime numbers between 0 and 12? So, the list of prime numbers from 0 to 10 will just be 2, 3, 5, 7, and 11. And again, or numbers that can divide 4 is not just 4. What else can divide 4? 2. So there are more numbers that can divide 4. You can divide 4 by 4, which is, what is 4 divided by 4?
1.
You can divide 4 by 2, and what is 4 divided by 2? 2. Unlike 2, 3, 5, 7, which are prime numbers, the only number that you can divide it with is that number itself. So the composite numbers from 0 to 12 will be the numbers that are not prime. So it's 4, 6, 8, 9, 10, and 12. Because can you think of a number to multiply by itself will equal to 8?
Oh, I see.
No, right? So give me another one.
16.
16 is, yes, because 4 and 4 is 16. Give me another one. Give me another square. 25 it is a square because 5 and 5 is 25. Give me another one. So that is why knowing your math language and your symbols are important. Because if you know your squares, 1, 4, 9, 16, 25, 36, 49, and so on, you know that you can break it apart as a factor of those numbers. Alright, so now that we know prime numbers, composite, and squares, we're going to work on factoring. What are the 2 numbers that you can think of that would, when you multiply, will equal to 4? 2 and 2. Is 2 a prime number?
Yes.
Yes, because that's the smallest prime number, right? And that's what you just did. You did prime factorization or breaking apart a number to its prime factors. Because 4 its prime factors will be 2 and 2. Give me the first factor that you can think of for 6.
2 and 3.
2 and 3. Is 2 and 3 both prime numbers?
Yeah.
Yes. And then you're able to factor it using the prime factorization. So 4 is 2 and 2, 6 and 2 and 3. What about 21?
3 and 7.
3 and 7. Is 7 a prime number?
Yeah.
Yes.
Is 3 a prime number?
Yes.
So you're done. 3 and 7 are prime factors. Now, are all prime factors just two numbers that you multiply to each other will equal to that number? No. Sometimes you will have more prime numbers to come up with that number. 12. Give me the first factor that you could think of for 12.
1 and 12.
1 and 12. Alright, 1 and 12. However, is 12 a prime number?
Yes. I mean,
No.
No, we can still break it apart, right?
Neither is 1.
Hmm?
So neither is 1.
But 1 is 1 and 1, so we can still break it apart. But 1 is not a prime number nor a composite.
Because it's just 1.
It is just 1. It's a special case. But 12, we can still break it apart. Think of another
3 and
fact.
4.
3 and 4. Now, is 3 a prime number?
Yes.
Is 4 a prime number?
No.
No. We can still break it apart, right?
2 and 2.
2 and 2. And this is what I'm saying, that prime factorization is not limited to only two sets of prime numbers. For 12, we have 3. We have 3, 2, and 2. Because we need to break apart the number into its prime factors in order for you to understand fractions. Alright? So do you understand why 12 is 2, 2, 3?
yes.
Okay. What about 29? Here.
Yeah, 29 and 1.
Because 29 is a prime number. So, knowing your multiplication table or mastering your multiplication table will give you the confidence to like say, oh, 29 is a prime. No, it's just 29 and 1. 12, oh, it's 4 and 3, so it's 2, 2, 3.
Breaking it down.
Breaking it down. 18, do this in your head. Now, since I think that you are advanced than basic, compared to the students that I used to have in this workshop, let's do mental math. Give me the prime factors of the numbers that I'm going to give you in your head. Let's start with the easy ones.
Okay.
Quickly, 30.
I just did that.
Okay, yeah. Say it again.
It's, 2, 3, 5.
All right.
There
9.
you go. 5, 3.
3, 3.
22.
11 and 2.
24.
6 and 4.
No, 6 and 4 are not primes.
2, 2 and 3, 3.
There.
Yeah.
2, 2, 2, 3.
Oh, 2, 2, 2, 3. Okay.
16.
4 and 4. No. 2, 2, 2, 2.
Yeah,
2, 2,
2,
2.
2, 2.
Good job. Now we're talking. Now you're ready to simplify a fraction. Now, simplifying fraction can be difficult to a lot of students because we were taught to simplify a fraction, you need to think of the biggest number you could think of that could divide the top and the bottom to simplify, right? This is the easier way. Okay, first, before I simplify, if I have 5 over 5, what is 5 over 5?
It's 1.
1. What is 7 over 7?
1.
1. What is 3 over 3?
1.
1. So it's safe to say that when the numerator and the denominator are the same, it's equal to 1 because that's the rule of mathematics, right? Now, 6 and 4, let's do prime factorization. What is the prime factorization of 6?
2,
2 and
3.
2 and 3, that's right. What about 4?
Almost. So 2 and 2.
2 and 2. Now, why did I break it apart? Because this is how we simplify fraction. Why? Because if you have a common term, a common number, you can cancel it out, and you are left with 3 over 2. So the smallest number that you will have is your simplest form of your fraction. So the simplest form of 6 over 4 is 3 over 2. So this is why knowing your prime factorization will help you simplify fraction because it makes everything a little bit more visual. Because now you can cancel this and this. 15 and 25. Let's simplify this by using this technique, prime factorization. What's the factors of 15?
3 and 5.
Factors of 25?
5 and 5.
Can we cancel?
Yes.
Yes. What are we canceling?
5.
So the simplest form of 15 over 25 and 3 over 5, 15 over 25 is 3 over 5. Got it?
Yes.
Do you have a calculator?
On my phone.
You have your phone?
Yeah.
Can you divide 15 divided by 25?
0.6.
0.6. Now, can you please give me 3 divided by 5?
Oh, the same. 0.6.
Because when you're simplifying, you're not changing the value of your fraction, you are just making it smaller. Because in mathematics, remember what I taught you a while ago?
Yes.
We need to always have the simplest form of the answer and the problem. And this is another way of understanding why simplifying your problem is your goal in mathematics. So they're just the same, you're just making it smaller. And to be able to make it smaller, prime factorization will help. Because ultimately what you're doing is you are just finding a new version of 1. Because 2 over 2 is what? What is 2 over 2?
1.
It's 1. So this is just basically 1 times 3 over 2, which is the same, 3 halves. So you're just picking a number that will change your number so that you can apply it to mathematics. So 15 and 25, this turn into 1, so you're left with 1 times 3 over 5, so that's why it's just 3 over 5. What about 18 over 20? All right, simplify this. 9 is what?
It's 3 and 2. Oh, 3 and 2.
Right? What about 20?
5, 2, and 2.
5, 2, and 2. Now, all we need to do is to cancel. Once we have broken down our numbers, we can now simplify it by canceling. What can we cancel?
The 2, 2.
The 2, 2. And what's left? Can we cancel any of these anymore? No. So when there's nothing else to cancel, just combine them by multiplication. What's 3 times 3?
9.
What's 5 times 2?
10.
And that is the simplest form. So whatever is left, you just put them back together and that is the simplest form. So what you're doing is simplifying using the prime factors of your numbers. And why do you need to know prime factors? Because you will use this once you work out algebra like this. Factor this problem or factor this problem. And knowing your prime factors is going to help you answer this algebra problem later on. Not today. I'm just giving you a preview. Alright? So 2, 3, 3, 2, 2, 5, cancel them and you have 9 over 10. Alright, now that you know how to simplify, we're going to move on multiplication. Now there are 4 different operations in fractions. Multiplication, division, addition, subtraction, right? The easiest problem to work on is multiplication and then division. Subtraction and addition will be a little bit more complex. So we're going to use the easy operation first, which is multiplication. Alright, when we were younger, we were taught that to multiply numbers, all you need to do is to multiply across, right? If I have 2 all over 5 times 1 all over 3, all I need to do is to multiply across. 2 times 1 and 5 times 3, which is 2 all over 15, right? However, there is another way on how to multiply fraction using the prime factors. And why do you need to do that? So that you don't end up multiplying big numbers. Because if it's a big number like 15 over 5 and 25 over 3, some students will just, it's too big. I'm going to use the calculator to multiply this. But we are going to be using the technique that we have a while ago. 15 over 25. Can we factor out 15?
Yes.
Can we factor out 5?
No.
Can we factor out 25?
Yes.
Can we factor out 3?
No.
So we're going to change 15 over 25 to its prime factors. What's the prime factor of 15?
3 and 5.
Yes. How about 25?
5 and 5, 30? No, just 5 and 5.
5 times 5 is 25, right? And we did not change this, right?
Yes.
So we'll just copy it. Now, what do you notice about our new equation? We can cancel some of them now. What can we cancel?
A 5 and a 3.
And the?
3 as well.
And what else?
Oh, another 5.
So what is left? 0 or 1?
I want to say 1.
And that's correct. So that's the answer. When you multiply 15 over 25 and 5 times 3, it is equal to 1 because you canceled all the factors. So sometimes you can cancel all of them, sometimes you can only cancel some of them. So this one is equal to 1. What about this one? So let's use the same technique. Can we factor out 21?
Yes.
How about 3?
No.
6?
Yes.
Okay. So we are going to multiply 21 over 6. What's the factor of 21?
3 and 7.
What's the factor of 6?
2 and 3.
And then we will just copy 3 and 7, right?
Correct.
Okay. Now for the fun part, canceling. So we're not multiplying big numbers, we're canceling common numbers. And what can we cancel?
The 3s and 7.
What's left?
3, 2.
And that is the product of the two fraction. 21 over 6 times 3 over 7 is equal to 3 over 2. So what you're doing is you are simultaneously simplifying and then factoring at the same time. I mean, simplifying and multiplying fraction at the same time. That's why you need your technique, right? So this is your introduction to algebra, because this is how we multiply problems in algebra. We always factor. How about this? See, if I'm going to answer this, I'm going to factor the numbers that are not prime. And that is 25 and 22, right?
Yes.
So I'm going to copy 2 over 5 and split 25 into,
5, 5. Did that, and then 11.
and 22 is?
11 and 2.
And then I'm going to cancel the common terms, which is,
5 and 5. And 2 and 2.
and what is left?
5 and 11.
That is why it's important that you know the syntax or how we do things in mathematics so that it makes sense. And this is basically why we're doing factoring a while ago, so I can connect it here. Imagine if I just teach you this technique without understanding prime numbers. Because in mathematics, it's all about steps. You need to have this skill, and then once you have mastered certain skill, now you can move on to the next one, to the next one, to the next one. You cannot do shortcuts. Otherwise, you'll get lost. That's why, that's one technique that I always tell my students. You need to have patience, and you need to have accuracy. And that is basically what you're doing here. Patience and accuracy. How about this one? Multiply this. What do you notice about this problem?
They're all prime.
They're all primes. So that means you cannot break it apart. So what else can you do if you cannot break it apart?
Multiply.
There. That's the only thing you could do. And what's the answer then?
I have 21 over 10.
And that is the answer.
Okay.
So again, confidence, you acquire it through practice. You don't acquire it by just watching videos, by just sitting in a math class. You need to really use it and apply it, because the more you use it, the more you get better at it and the more that it makes sense. And that is why you need to do a lot of practicing. Now, dividing. We're done with multiplication. That's all there is in multiplication. And dividing, it's connected to multiplication. You just need to add one more step. In multiplication, you just multiply across, right?
Yes.
But in division, there is an added rule. The rule is you copy the first fraction, let's say A over B, and then you take the reciprocal of the second fraction, also known as flipping it. And the reciprocal of C over D is
D over C.
D over C. And then you multiply. So that is the rule. In division, you need to perform another step, which is to copy the first fraction and to take the reciprocal of the second fraction, and then you use the multiplication rule. So, how are we going to use this formula? basic math formula, so we can multiply two fractions. So I'm going to work on the first one, okay? So you have 5 over 3 divided by 25 over 6. According to the rule, copy the first fraction and take the reciprocal of the second fraction. So 25 over 6 is?
6 over 25, 30 over 75.
And then you multiply, right? Now, the problem with 30 and 75 is you still need to simplify it, right? What I want you to do is to be consistent with the rule that we're using. So we're going to factor again. So 5 and 3, can we factor out 5 and 3? No, so we'll just copy it. Can we factor out 6 and 25?
Yes.
Yes, which is?
2 and 3 and 5 and 5.
And the reason why we're using this technique is because we are trying to avoid multiplying big numbers and then simplifying it afterwards. And by doing so, all we need to do is to cancel out. And what is left?
2/5.
So 5 over 3 divided by 25 over 6 is 2 all over 5 by factoring and multiplying.
Let me copy that now, please.
Okay, let's do this. 6 over 4 divided by 9 over 14.
3, 2.
Okay, let's see. So step 1 is to follow the formula, copy
6, 4,
and switch.
14.
And then break it apart. Factorable, 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 factorable. So I can factor all of them, right?
You can factor 14 and 9?
Yeah.
Yeah.
3 and 3, 2 and 7.
Right? So let's start with 6. Can we factor 6?
3, 2.
How about 4?
2, 2.
14?
2, 7.
9.
3, 3.
So we have a bunch of factors. And all we need to do is to cancel the common term that we don't need. And they are, what can we factor first?
2 and 2. 3 and 3. Another 2 and 2. So you got 7 over 5.
7 over 3.
7.
7 over 3, which is more than 7 over 3.
And that is the answer.
Okay, I got it.
And again, practice. Because the more you practice, the more that you will spot what numbers are prime and what numbers are composite. Because that is the whole reason why I'm doing this. Because you cannot rush through mathematics. You really need to build your patience and confidence in building out your work in mathematics. And this applies to all. May it be factoring, may it be solving for algebraic equation, may it be any other math problems that we're going to be working on in the future. It's all the same thing. You just need to follow all the steps and don't skip a step. Because otherwise, you will make a mistake if you rush. Okay, do this. Divide it. Going to
12.
use the formula. Because you cannot cancel them, right?
Yeah.
So it's just 4 and 2.
I know.
Is there anything to cancel or factor? No. So there's nothing left to do but multiply.
Correct.
So the answer is
10 over 21.
yes.
Yeah, it's right here.
And now we're done with multiplying and dividing because now we're going to move on to addition and subtraction. When we're adding and subtracting fractions with different denominators. Because when you're adding and subtracting numbers or fractions with the same denominator, the rule is pretty simple. You copy the denominator and then you add the top. That's it. But when you have different denominators, it's a different story. That's why we're going to do that one. Okay. So let's have an example on how we use this formula, which is pretty basic. You multiply A and B, you multiply B and C, and you multiply B and D. That's all you need to remember. This, and that. Okay? That's basically what the formula is asking you to do. Now let's apply the formula. It's the same as addition and subtraction. The rule will be the same as adding and subtracting. Now, 2 over 3 minus 1 over 5. They don't have the same denominator, right? So we're going to apply the formula. The formula is You multiply that,
10,
and you subtract it with the product of this, which is
7. So
3,
10 minus 3 is 7.
and then this and this, which is... No, I'm just showing first how I use the formula
Oh,
in this problem so that it makes sense.
Okay.
So now that I use the formula, now I'm just going to simplify it, which is 10 minus 3 all over 15, right? 2 times 5 is 10, 1 times 3 is 3, 3 times 5 is 15. And now I have a problem that is really simple. What's 10 minus 3?
7, 15.
And that is the answer. So when you subtract 2 over 3 minus 1 over 5, the answer is simply 7 over 15. So you did not think of the least common denominator. You did not think on how to make the denominators look the same. You simply used the formula. And that is how we add or subtract fractions with different denominators. As simple as this. So if I have this, can you please add this? Using the new technique that you've learned. So I'm going to multiply 5 and 6,
Right.
and 4 and 3, and 3 and 6. Which is, 5 and 6 is,
30,
Oh,
4 and 3 is,
12, 40,
3 and 6 is,
18, 42 over 18.
it's 42 over 18.
I multiplied it different, I thought it was 2, and I did 3.
Let's simplify it. Let's see if we can simplify this. What are the prime factors of 42? 7 and 6, right?
6.
But 6 can be broken into 3 and 2.
3 and 2.
7, 3, 2. 18,
9 and 2.
which is,
3
3 and 2.
2.
is there anything we can cancel?
Yes, so 3
7 over 3.
So the answer is 7 over 3. So what will happen if the denominators are just the same?
You just regular add it, so it's 11 over 21.
And again, because in mathematics, you need to recognize, you need to look at the problem first and see what you're supposed to be doing. If the fractions are different denominators, use the formula, but if the fractions have the same denominator, you don't need to worry about the formula. Because the formula is pretty easy. The formula is to copy the denominator, and then you just add the numerator. So we have 11 over 2. And again, ito po si Dr. Esperanza at maraming salamat sa panonood ng aking math video. And if you happen to like my video, please like, share, at mag-subscribe na rin kayo sa aking YouTube channel para marami na akong estudyante na matulungan na kagaya nyo. So kung meron kayong mga klase, kaibigan, mga pinsan na nagsastruggle sa mathematics, share nyo na yung YouTube channel ko para mas marami na kayo na matulungan ko. See you again next time. Bye!